Imagine a world without motors. Difficult, isn't it? The magic behind the operation of the tiny motors in your toys, or even the larger ones in your car, is a marvel of engineering called the DC motor. From the spinning wheels of your favorite toy car to the massive industrial machinery that shapes our world, DC motors play a crucial role. But what makes these motors tick? How do they transform electrical energy into mechanical motion? In the heart of these machines lies a simple yet fascinating principle. Ready to discover it? A DC motor, in essence, is all about conversion. It's a bit like a magic trick, where the magician transforms one thing into another. Except in this case, the magician is the motor, and the trick is turning electrical energy into mechanical energy. Now, let's break down this magic trick. The first thing to understand is that electricity and magnetism are two sides of the same coin. When an electric current passes through a wire, it creates a magnetic field around it. Think of it like a river. The water flowing is the electric current, and the riverbanks are the magnetic field. In a DC motor, we take advantage of this phenomenon. We have a coil of wire, which we call the armature, placed within a magnetic field created by permanent magnets. When we pass current through this coil, it creates its own magnetic field. This field interacts with the one from the permanent magnets, creating a force. This force makes the coil rotate, and voila, we have movement. But that's not all. The direction in which the coil rotates can be controlled by changing the direction of the current. If you remember your science classes, you might recall that, like poles of magnets repel and unlike poles attract. By switching the current's direction, we can control which poles are facing each other, thus controlling the rotation. So it's all about using electricity to create a magnetic field that then generates motion. Simple, isn't it? Now that we understand the principle, let's meet the key components of a DC motor. First up, we have the armature, the heart of the motor. It's the part that rotates, and it's here where the magic of energy conversion happens. The armature is wound by conductive wire, and it's this wire that carries the electric current, causing the armature to spin. Next, we have the commutator. This rotating switch inverts the current direction within the armature coil. It works hand in hand with the brushes, conducting electricity from a stationary part to the rotating armature. The brushes, usually made of carbon, maintain an electrical connection with the commutator as it spins. They're the silent heroes ensuring the current keeps flowing. Lastly, there's the field magnet. This stationary component creates a magnetic field that interacts with the armature, causing it to rotate. Each part has a crucial role to play in converting electrical energy into mechanical motion. In just a few minutes, we've traveled from the heart of a DC motor to its outer components. We've journeyed through the fundamentals, understanding how direct current motors operate. We've seen how they convert electrical energy into mechanical energy, a fascinating feat of engineering that powers many of our daily devices. We've uncovered the core principle of DC motors, delving into the magic of electromagnetism and the pivotal role it plays. We've met the key players, the armature, the commutator, the brushes and the field magnet, each playing a crucial part in the perfect choreography of energy transformation. We've seen how the simple yet potent idea of energy conversion shapes the world around us, from the smallest toy car to the largest industrial machinery. This knowledge opens a window into the intricate dance of science and engineering that lies beneath the surface of our everyday lives. Next time you see a motor at work, remember the fascinating process behind it. Thank you, fantastic viewers, for being a part of the Fix Flare Tech community. Your support means the world to us. Stay tuned for our next video, where we'll unravel another fascinating tech topic. Until then, keep exploring, keep learning, and I'll catch you in the next one. This is MQ Joshi, signing off from Fix Flare Tech. See you soon.